Hello students, now let us start today's session. In today's session we are going to start a new section which is your section A. Now section A is all about investment decision. When I talk investment decision, primarily we are talking about capital budgeting techniques. So the area which we are entering into primarily is capital budgeting techniques. Now this capital budgeting concept was also there in your inter level, right? Now we are going to study all that what you have learned at inter level, and also many more new concepts will come up. Now there are 3 study notes in this section. Study note number 1. Now study note number 1 is all about project planning and control. This is the name of the study note, project planning and control. Primarily we are going to study discounted cash flow techniques and non-discounting cash flow techniques, plus estimation of project cash flows. Now there are approximately 12 to 15 questions given in your module that we will primarily focus on. Then there is another study note number 2, which is totally a new study note for you. You have not studied anything about it in the inter level. That is evaluation of risky proposals. Now here the element of risky proposals. Now here the element of risk will be there, and there are approximately 10 to 12 new concepts are there, and many questions are there in your CMA module. 20 to 25 questions are there in your CMA module, and 10 to 12 new concepts will be covered in this study note. But the best part is that those concepts are very easy. So difficulty level is very easy. Now there is another study note which is study note number 3, which is all about leasing questions. Now here the concept of leasing of machine, leasing of plant will be introduced, where there will be a lessee party, and we have to evaluate the deal of lease, whether the deal of lease is beneficial or not. Since its benefit comes in 5 to 6 years, it's a long-term planning, so we are using capital budgeting techniques in the leasing chapter. Now there are approximately 9 to 10 questions in your study module, and we are going to focus only on CMA module questions while studying section A, because it covers complete area in your CMA module. The question is exhaustive questions. They cover maximum possible area. So we are going to focus on CMA module questions directly. We start the study note with the CMA module questions only. So 9 to 10 questions are there in your leasing chapter. We are going to start with leasing first. I'll start with study note number 3 first, so that it is finished first, and then I will shift to study note number 2 and then 1. Now before starting these study notes, some basic concepts have to be taught. Now these basic concepts are what? Basic concepts. Before starting any study note number 1, 2, 3, we have to study some basic concepts. There are computation of, these are concepts which you must have studied in inter level, but we are going to study again in final level so that there is no confusion. Now computation of or concept of present value, future value, compounding concept, annual compounding, then there is semi-annual compounding, then there is your monthly compounding, and then here comes continuous compounding. This continuous compounding concept will be used in derivative chapter. So compounding we will learn. Then present value annuity factor, when to be used. Future value annuity factor, or simply plain you can say present value factor and future value factor. These are different. These four words are different. This is present value factor and this is present value annuity factor. This is very important. This is future value annuity factor and this is future value factor. Then we have to study the basic NPV computation, net present value concept, basic, so that I can teach these three chapters. Before starting these three study notes in the order of study note number 3, 2, then 1, we are going to study these basic concepts first and then we are going to start those study notes. So let us start these first, understanding what is present value, how to look up the tables, what does present value factor table denotes, when to use PVAF and PVF. You won't believe many students, even when I was the student, I myself didn't understand when to use PVAF and when to use PVF. So these are small concepts. Let us clear from my angle how I take these concepts as, and then we are going to start with leasing chapter. So let us start with this basic concepts. Okay. Now the first prime question is, what is the difference between simple interest and compounded interest? So what is the difference between simple interest and compound interest? So let us understand this and derive a formula out of it. Now simple interest means that suppose 100 rupees is invested at the rate of 10% for 2 years. So how much will you get under simple interest? Under simple interest calculation, you will get rupees 100, the principal you will get, plus you will get 10% of interest on 100 rupees, 10% I can write 0.10, and this interest you will get for 2 years, right? So basically you are getting 100 rupees and 20 rupees, right? So you are getting 120 rupees total principal and interest. This portion represents your interest portion, where you get interest at the rate of 10% for 2 years, right? Now if we go for compound interest, now what is the difference between simple interest and compound interest? Now in compound interest calculation, in the simple interest calculation, you are getting interest only on principal, right? But in compound interest, you get interest on principal as well as interest on interest also. What did I just say? Under compound interest, you are going to get the interest on principal, interest you will receive on principal, as well as you will receive interest on interest also. Yes, on interest also you will receive interest. How that will happen? See, suppose in the same example, 100 rupees in invested at the rate of 10% for 2 years. Now rupees 100 is invested for 2 years. First let us talk about the first year. Now if I say rupees 100 invested for 2 years, annually compounded at the rate of 10%. Now what does this implies? Annually compounded. Now rupees 100 is invested at the rate of 10%. Now for the first year, if we do the computation, since the amount is invested for 2 years, but we will do the computation annual wise. 100 rupees is invested at 10%. So how much it will become after 1 year? How much it will become after 1 year? 100 rupees will remain as such 100 rupees plus 10% interest will accrue on 100 rupees. So rupees on 100, 10% interest if I compute, it is 0.10. If I take 100 rupees common, how much is left? 1 plus 0.10, and this comes out to be rupees 110. So after 1 year, your 100 rupees becomes 110 at the rate of 10%. Now, are you withdrawing your investment, or you have invested for 2 years? You have invested for 2 years. So you are not withdrawing your money. Now in the second year, you will not get interest on 100 rupees. No, you will get interest on this amount, 110. That is the principal and the interest both together, 100 plus 10 rupees. You will get the interest now on 110. So 110 you will get interest on at the rate of 10%. How much it will become? 110 you will get. That's now the principal for the second year. Plus you will get interest on 110. So rupees 110. So 100 rupees, 110 rupees if I take common, what is left behind? 1 plus 0.10, right? Now this is coming out to be 121 on the calculator. But I want to create a formula out of it. Now after 2 years, the investor will get 121 rupees, right? But I want to create a formula out of it. Now instead of 110, I am going to write this thing. 110 is equal to 100 rupees plus 1 plus 0.10. So I am going to write this thing. Rupees 100, 1 plus 0.10, and the same thing 1 plus 0.10 from here. So instead of 110, I have written this computation, 100 into 1 plus 0.10. Now this, if you see, this becomes 100 and 1 plus 0.10 whole square I can write. Now this is equal to 121. Now can I create a formula out of it? What is this 100 rupees? This was my principal which I have invested. So can I write principal? 1 plus, what is this? 10%. This is my rate of interest. This is the rate of interest at which, this is the speed at which money is increasing. This is the time value of money with which the money is increasing. 10% rate of interest. For how many years I have invested? 2 years. Is equal to, now this is the amount which I will get after 2 years. So amount. Now I want to change little bit this formula. Can I write like this? 100 rupees I have invested today, right? And after 2 years I am getting 121 rupees. So 100 rupees I invested today. So this is the present value. 1 plus R into 2 years is equal to, now 121 I will get today after 2 years, after 2 years. So this is the future value. So can you see I have created a formula from here that if the present value is given and you want to compute the future value, then this is the formula, this is the rate of interest, and this is the time period, 2 years, the amount which you have invested. Now what is the difference between simple interest and compounded interest? In the simple interest you were getting the interest only on the principal for 2 years. But in the compounded interest, you are getting interest on principal as well as on the interest also. Now if you see here, see the calculation, 100 rupees becomes 110 in the first year, and 110 is also invested because you are doing compounding annually. So every year whatever the interest and principal becomes, that on that you will get the interest in the second year. Now suppose, this is very important, please observe. Now in this formula, this is your principal. This formula you have studied in your school level, right? Basic information I am telling you. This is nothing very big thing, but sometimes we tend to forget. So that's why we are revising it. Now this formula, P plus 1 plus R raised to power N is equal to amount. Now if I say the compounding is not annually, if I say compounding is not annually, compounding is semi-annually. Now semi-annually means that rupees 100, on rupees 100 you will get interest first for 6 months. Then whatever amount will become principal plus interest, on that amount you will again get interest for 6 months. Then on the same, whatever amount will become, on the same amount you will get interest for 6 months, then 6 months. 4 times you will get interest on that amount. You will not get in the intervals the interest. I am telling the interest calculation will be done 4 times. So basically the formula then becomes amount is equal to principal into 1 plus R raised to power N. here you have to multiply with the number of times compounding done in a year. And similar, you will also multiply here. Number of times the compounding is done. This is called M. Now what will happen? P into 1 plus R, M, N into M. What does this mean? Suppose if I say it's a semi-annually compounding. That means after every 6 months you are doing interest, you are doing the interest calculation. So in a year, how many times you are doing the interest calculation? Twice, 2 times. Compounding is done 2 times. So 2 times you will multiply here. So P into 1 plus rate of interest is 0.0. Number of years is 2 years. But every year you are doing compounding how many times? 2 times. So basically 4 times compounding is done. Every year you are better calculating interest, then again interest, then interest, then interest. So 4 times you are doing interest, and for 6 months the interest rate is not 10%. 10% was the interest rate for full year. You divide M we have calculated how many times? 2 times. 2 times you calculate, divide here also. So interest rate for 6 months is 5%. So basically you compute interest on 100 rupees at the rate of 5% for 6 months. Plus again you on next 6 months you will do the same. You will compute interest at the rate of 5%. This you will do 4 times in 2 years duration. So basically what you have to remember is the formula, this formula. Ultimately formula is amount principal into 1 plus R divided by M, N into M. Now M represents number of times you are doing compounding in a year and N represents number of years. But maximum questions are not of semi-annual compounding. No. Maximum questions are of annual compounding. So currently in the leasing chapter, no such issue will come up. Semi-annual compounding or anything like that. What normally questions are of annual compounding. So we are getting back to our original concept, that is the present value and the future value concept. Now let us focus here. I want to tell you something. Now in this whole illustration, just a second. In this whole illustration, present value today, how much you are investing? 100 rupees. For how, at what interest rate? 0.10 for how many years? 2 years, right? And this becomes your 121. I just want to know the figure of this portion. Now how much this portion will come out to be? 1 plus 1.10 into 1.10. So this is coming out to be 1.21 is equal to 121. Now what is this 1.21? This is called as future value factor. Future value factor. This is called as future value factor. Please understand carefully. Future value factor. Factor means 1 rupee. Factor means 1 rupee. Now what does this mean is that if you invest 1 rupee, today for 2 years at the rate of 10% annual compounding, then it will become 1.21. So this is the future value of 1 rupee. So it is called as future value factor because factor means 1 rupee. So it is the future value of 1 rupee. Now since you know the future value of 1 rupee, you can compute the future value of any number. 100 rupees, since you know 1 rupee will become so much. So 100 rupees will become how much? 120 rupees will become how much? 400 rupees will become how much? So basically, if you know 1 rupee will become how much after 2 years, if you multiply the same with any principal amount, you will get to know the amount you will receive in future value. So basically this 1.21 is future value factor. Now whenever I will ask you that what is future value factor, what will you say? Ma'am, factor means 1 rupee. So basically this is the future value. 1.21 is a future value of 1 rupee. And since we know 1 rupee will become 1.21 rupees after 2 years at the rate of 10% compounded annually. So how much? 100 rupees will become 121. So the first, it's now the time for creation of formulas. So basically, present value, if multiplied with future value factor, it becomes future value. So if you ever want to compute future value, what do you have to do? If you want to compute future value of any amount, you will be given present value, multiply with future value factor. Basically, this whole equation can be represented like this: future value into 1 plus r raised to power n is equal to future value. So can I correlate that what is future value factor? That is 1 plus r raised to power n. Now do not forget this. Learn by heart. Future value is 1 plus r raised to power n. Okay. Now, can I say that if I want to compute future value, I have to multiply present value with future value factor. Now from this, I am going to now create one more formula from this equation. If I want to compute present value, and if I take this LHS figure on the RHS side, this will become like this. If I will take 1 plus r raised to power n, the LHS side figure, to the RHS side, it will be divided 1 plus r raised to power n. So if ever I want to find out the present value, how will I find present value? I will take the future value will be given to me into 1 upon 1 plus r raised to power n. Now what is this 1 plus r? 1 plus 0.10 raised to power n. N means 2 years, right? N means number of years. Here m is also multiplied, but since there is annual compounding, so number of times compounding done in a year is 1 only. So 1 multiplied by here is 1, right? So this is 1 plus 0.10 raised to power 2. Now let me do the calculation. Future value is 121, we know, into 1 upon, what is this figure representing? 1 plus 0.10 whole square. Now if I take the calculator, what do I have to do is, I have to 1 divide by, now this is what? This is 1.10. 1 divided by 1.10 equal to, now how do we do the calculation? Please see. I can see, make you see on this screen. What do? You take 1 divide by 1.10, okay, 1.10 equal to, when you press equal to once, that means it is raised to power 1. Since there is raised to power 2, you press equal to again. Now how much it is coming? 0.826. So this figure is 0.826. Again, let me do it. 1 divided by 1.10 equal to 1 time equal to 2 time, because this is square. This is how you do the calculation. Okay. So it becomes 0.826. Now what is this will become rupees 100. Okay. So this is future value. This is present value. Now what is this? This is present value factor. PVF. And what does it imply? We have to understand this. This is factor. Factor means 1 rupee. So this 0.826 is present value of 1 rupee to be received after 2 years. What have I written? If you want to receive 1 rupees, if you want to receive, see, just a second. Now, whatever I am teaching now is very important, because normally in the questions we have to compute present value and future value inflows are given. So to bring the future value inflows at present value, this is how we do. First of all, we understand what is present value factor. What is present value factor? Basically, this is the present value of 1 rupee. What does this mean? That if you want to receive 1 rupee after 2 years, and the money is getting compounded at the rate of 10%, then how much should you invest today? You should invest 0.826 today. This is the present value. Then only you will get after 2 years 1 rupee. So if you want to get 1 rupees after 2 years, you have to invest this much. So if you want to get 121 after 2 years, how much should you invest? Simple unitary method. Let me show this unitary method, through unitary method. Now let us say like this. If you want to get 1 rupees after 2 years, how much should be invested today? How much should be invested today? 0.826. So if I want to get 121 rupees after 2 years, how much should I invest today? 0.826 divided by 1 into 121. So you will get 100 rupees you should invest today. The same thing we have done, 0.826 into 121. 0.826 into 121. Now coming back to here, please observe. Now this is 0.826 into 121. You are going to get 100 rupees. Now 0.826 is called as present value factor. Now if you forget what is present value factor, then read the word present value factor. Factor means 1 rupee. This is the present value of 1 rupee. Present value. So 1 rupee you will get after in the future. So if you want to get 1 rupee in the future, what is its present value? Now this is all about understanding. Now let us create a formula. Now what is the formula? 100 rupees was your present value. If you want to find out present value, future value will be given. Then multiply with present value factor. Now present value factor, so basically net conclusion is that if you want to find out present value, then multiply with present value factor. Multiply what with present value factor? Future value. Now if you want to find out future value, then multiply, what is given then? Present value is given. Multiply with future value factor. Whatever you have to compute, multiply with that factor. So again, if you want to find out present value, then multiply the given information with the present value factor. Now what is present value factor formula? Present value factor formula is this. That is 1 upon 1 plus r raised to power n. Is it okay? So now if you do this, if you observe these two computations, so 4 things have come up. Now 4 things have come up. Conclusion time. 4 knowledge we have got. Present value factor is 1 upon 1 plus r raised to power n. Future value factor is 1 plus r raised to power n. And this is m and also, but we don't write because normally compounding every year is once only. So we are avoiding this. Okay. We are not writing this. Now, okay. And now what you have to find, if you want to find future value, present value is given. Now with what you should multiply? Don't get confused. What do you want to find out? Future value? Then multiply with future value factor. If you want to find out present value, what will be given? Future value will be given. Multiply. What do you want to find out? Present value? Okay, multiply with present value factor. Okay. Now future value is the future value will be given to you in these, whatever the situation is. One thing will be given to you, other thing we have to compute. Whatever we have to compute, multiply with that factor only. Okay. Now this 0.826, my dear students. Now this 0.826 here, 0.826, what was it? It was basically present value factor at the rate of 10% for 2 years, right? Now why am I repeating this? Because I want to show you in the table. This is basically present value factor at the rate of 10% for 2 years. If somebody asks you the meaning, you know the meaning, that present value factor, factor means 1 rupee. This 0.826 is the present value of 1 rupee. 0.826 invested at 10% for 2 years you will get 1 rupee, right? So 0.826 you can also compute through a table. Now in our book in the last pages you have been given the tables. Now I'll show you. This is the table, just a second. This is the table of the present value factor table. Now if you observe, if 10% money is invested after 2 years, now this 0.826 is what? You will get 0.2826 after 2 years. No dear, this is present value factor, means 1 rupee invested for 2 years at the rate of 10%. Sorry, let me correct myself. If you want to get 1 rupee after 2 years at the rate of 10%, how much should be the present value? 0.826. So either you can do the calculation on the calculator, or you can go through the table also. In exam, complete table is not given. Please let me make it clear. Only the extracted value will be given of 2-3 percentages, so that you can take the relevant figure out of it. Okay. Or you can do the calculation through calculator also. So this is the present value factor table. Now please write down all this. Then we'll move further. I hope it is now clear what is the difference between simple interest and compound interest. Please copy it. Pause the screen and copy it. Then we have to understand many more concepts. I'm changing the sheet. I'm changing the sheet. I've changed the sheet. Please copy it. Yes, I'm changing the sheet. Please pause the screen and copy this. You don't have to memorize the explanation, total explanation. You just have to remember the last 4 conclusions that we have drawn. So now we have understood these 4 concepts, PVF, and future value factor, and the 2 formulas. Going further now we have to understand the usage of how mainly present value factor is normally used. Present value factor is normally used in NPV calculations. Now what is NPV? Net present value. This is a discounted cash flow technique. This is a discounted cash flow technique of project evaluation. Now these are high-fi words that we are using. Now please understand this term, this NPV calculation from very basic, and how PVF is used in everything. Let us take an example first. For example, suppose I have 1 lakh rupees in my hand. This is my capital. And I want to invest this capital. There is a project which is available in which I can invest this 1 lakh. I am thinking whether I should invest my 1 lakh or not. Now this 1 lakh is given to me by bank at the rate of interest rate of 10%. So definitely if I invest this money in some project, I should be getting at least 10% of return, because I have raised this capital, through a bank. Basically this is a debt. So I have raised this debt at the rate of 10% per annum, and I want to invest this money in a good project which should at least bare minimum yield 10% of return. Okay. Now there is a project A which is available. I am evaluating this project whether I should invest in this project or not. Now this project, if I invest 1 lakh, I have to invest today. So investment is normally done today. Now today is called zero period. Today I am going to invest money in this project, and this project will yield returns. That is, this project will give me cash inflows till 3 years. First year it will give me cash inflow of 40,000. Second year also it will give me inflow of 40,000. Third year also it will give me an inflow of 40,000. So every year it is going to give me equal cash inflows. In my example, whenever there is an equal cash inflows, we say it is even cash flows. And we also say it is a case of annuity. When every year inflows or outflows is similar, same, then we say it is a case of annuity. Now coming back to our example, if I invest 1 lakh rupees in this project, I will be getting 40,000 rupees of cash inflows every year. Now I am thinking whether I should invest 1 lakh in this project or not. Investment is done today and inflows are coming over a period of time, 1 year, second year, third year. So it's a long term project. Secondly, I need bare minimum 10% of interest. Return on capital employed should be 10%, because this is my cost of capital. I have raised capital at 10%, so this should be bare minimum my ROCE. ROCE is what? Return on capital employed. So let me check whether this money, if I want to invest in this project should give bare minimum 10%. So let me check whatever inflows are coming. Are these inflows coming, or I should say, are these inflows compounding at the rate of 10% per annum? Let me check. Okay. Now, before going further, please clear one doubt. Do you understand this thing or not? In my previous example, rupees 100 annually compounded at the rate of 10% for 2 years became 121 in my example, right? This is future value and this is present value, right? This is future value and this is present value. Now when you just a second, when you compute the future value, please understand, when you compute the future value from present value, when you compute the future value, we say we are compounding. And when you are computing the present value using the future value, we say you are discounting. This process is called discounting. So one thing should be clear in your mind, that if you compute using present value, if you compute future value, if you are computing this is given and you are computing what? Future value, then you multiply with future value factor. This process is called compounding. And future value factor is 1 plus r raised to power n. But when future value is given and you are trying to find out present value, that is going back, reverse direction, then since you are finding out what present value, you have to multiply with present value factor. This should be clear in your head. Present value factor. This process is called discounting. Now future value was 121. into 1 plus 1 plus raised to power n, which was coming out to be 100 rupees. This was 0.826, right? This was present value factor. This process is called discounting. So 121 when discounted at the rate of 10% at for 2 years, it became 100 rupees present value. So why it became 100 rupees? Because 100 rupees grew at 10%. For 2 years, it grew to 121. If the same rate is used, please listen to this very carefully. If same rate is used, same compounding rate is used as discounting rate, then definitely 121 will become 100 rupees. What am I trying to say is that the speed at which the money has grown, the speed at which the money has compounded, if the same speed is used to discount the money, the same present value will come. Here the speed is used. When I say speed, I am talking about rate of interest. 100 rupees when compounded at the rate of 10%, it becomes 121. Now if I say 121 discounted at the rate of 10%, it will be equal to 100 rupees, because it was compounded at 10% and you are doing discounting at 10%, it will come out to be 100 rupees. But if you do the discounting at the rate of 8%, it will not be equal to 100 rupees, because since this 100 rupees compounded at 10% becomes 121, but when 121 discounted at the rate of 8%, it will not be 100 rupees. Definitely it will not be 100 rupees. It will be 100 rupees only when it is discounted at 10%. Right? Okay. Now, why am I telling you all this? Because in my question, my 1 lakh of capital, I need how much interest rate? 10%. Now there is there is a project A which is offered to me by company X. Now this project A is project of company X. So I'm talking to company's X manager and I'm asking him, sir, if I invest my 1 lakh rupees in your project, will I be getting 10% interest? He's saying, yes ma'am, my project gives you 10% interest. Now, if actually the project is giving 10% return, if actually this money 1 lakh rupees is compounding at 10% and becoming this amount, then after discounting this 40,000 at 10% should be equal to 1 lakh. If company X manager is correct, company X manager is committing me that ma'am, you are getting 10% return. Now if 1 lakh project is actually compounding at 10%, increasing at 10%, and it becomes this much, then definitely if I discount this figure and Mr. X is correct, then this all 40,000 inflows, future values, if discounted at 10%, should become 1 lakh rupees present value. Because if 100 rupees is actually compounded at 10%, and then the discounting at 10% should be equal to 100 rupees. So without getting confused more, let us check whether company's X commitment is true or not, whether this project is actually giving 10% return or not. Let me check this. How will I check? Very simple. Now the project is something like this. Year I will write here 1, 2, 3, right? And cash inflows, future value of cash inflows, how much every year? 40,000. Now I want to know its present value. How will I compute present value? If I want to compute present value, I should multiply future value with present value factor at the rate of 10%. Now what is the present value factor? Now I have to multiply this future inflows. This future cash inflow, this first future cash inflow is coming after 1 year. After 1 year I will get 40,000. Let me discount this. Since I am computing present value, this process is called discounting. Let me discount this. 40,000 I am going to discount at the rate of 10%. Basically I am trying to find out its present value. Now 40,000 this 40,000 I will be getting after 1 year. I want to find out its present value. So how will I do? This is future value. I'll multiply with present value factor. I will get present value. right? So present value, now I have to discount with 1 year. So present value factor at the rate of 10% for 1 year. Either I can compute this on calculator or I can look in the table also. If I go in the table and see 10% 1 year is how much? 0.909, right? Can you see? Sorry. Yes, can you observe? 10% for 1 year. What is the present value? 0.909. Okay. So I can write here 0.909 and I will multiply this 1 lakh with 0.909. 1 lakh into 0.909. This is coming out to be 90,900. Now what does this mean? This means that if you invest 90,900 today, after 1 year at the 10% rate, it will become, oh sorry, I multiplied wrongly. 40,000 into 0.909. This is coming out to be 36360. Okay, so if I invest 3630 today at the rate of 10%, after 1 year it should become 40,000. So 40,000, so let's say like this, 36,360 compounded at 10% will become 40,000, or 40,000 discounted at 10% becomes this much. This is the speed of increasing and decreasing. Similarly, this 40,000, second year 40,000 I am getting. Now I want to discount it to 0 period. So how will I do? I'll multiply with PVF at the rate of 10%. I want to bring it back to 0 period. For this is for 2 years. How much is this? Let's go back to table and see. 10% for 2 years is how much? 0.826. Sorry. 0.826. 0.826. Can you see 10% for 2 years? 0.826. Okay. So if I multiply with 0.826, how much am I getting? 40,000 into 0.826, we are getting 33040. Now please, my dear students, can you explain me? I am not interested in solving the question. I am trying to explain you something, that what is this 36,360 and 33,040 means. That if you invest 33,040 rupees today, 33,040 rupees today, after 2 years, annual compounding interest you get on interest, after 2 years it will become 40,000. This is what it means. And what is 0.826 means? 0.826 means that, what is 0.826? If you don't know, please speak its name. It is present value factor. Factor means 1 rupee. It is 1 rupee's present value. So if you need after 2 years 1 rupee, then today you have to invest 0.826. If after 2 years you need 1 rupee, then you have to invest 0.826 today. Then you will get 1 rupees after 2 years. So similarly, if you want 1 rupees after 2 years, you have to invest this much. So if you want after 2 years 40,000, then how much you should invest? Now this amount you are getting after 3 years. So after 3 years, if you want 40,000 rupees, how much should you invest today? So for 1 rupee, first of all, find out PVF at the rate of 10% for 3 years. We can compute this on calculator also. How? What is PVF formula, my dear students? 1 upon 1 plus R raised to power n. So 1 upon 1 plus rate of interest is 10% for 3 years. How will we do? 1 divide by, this is 1.10. 1.10 equal to, then 1 more equal to, then 1 more equal to, 3 times equal to, because it's raised to power 3. It is coming out to be 0.751, and same figure you will find in the table as well. See, I'll show you how much it is. 0.751. Can you observe? Okay. So going back, yes, so it's 0.751. 0.751 into 40,000, you get 30040. Basically, now what this whole thing implies is that if you invest, what this whole calculation implies, that if you invest this amount today, then you can get this amount at the rate of 10%. So basically, if the money is increasing at the 10% rate of interest, then how much should be invested today? How much should be invested? Now let's add this figure, 36360. I'm adding these three figures, my dear students. These three figures I'm adding. So how much is this coming? 36360 plus 33040 plus 30040. So 99,440 rupees should be invested. This is present value of cash inflows. But basically, what does this mean? That this amount should be invested. But how much money company X or project A wants me to invest? 99,440 rupees. No, they are asking me to invest 1 lakh rupees and they are giving me only this much return. That means they are not giving me 10% return, because if 10% return if they were giving me, then only this much amount should be invested. And they are asking me present value of cash outflow. They are asking me how much? 1 lakh rupees. So basically they are asking me excess amount. How much excess amount they are asking me? 560. Now this is called as NPV negative. But what does NPV negative implies? Give me a second. Now this is called negative NPV. NPV, that is net present value, is negative. But many students even doesn't know what NPV negative implies. It implies, first of all, what is the present value of cash inflow implies? That this is the amount that should be invested in order to earn 10% return. But what actual amount I am investing? 1 lakh. So that means because if 1 lakh is to be invested at 10%, then I should get more return. This means because 99,440 only gives me this much return. So 1 lakh rupees is giving me this much return. That means I am getting less than 10%. So since NPV is negative, it implies what? It implies that project is offering less than 10% return. That is less than cost of capital. Hence, I am rejecting the project. Hence, project is rejected. If NPV was 0, what does it mean? 0 when this amount will come 0? When 1 lakh minus 1 lakh will be there. That means 40,000's present value comes 1 lakh. That is, if you invest 1 lakh, then 10% rate, it will become 40,000 something. These inflows will be there. That means the project is actually giving you 10% on your money. Now, if by chance this is positive coming, what does it mean? Suppose this 99,440 instead of 99,440, 1,20,000 was written here. What does this mean? That in order to get, suppose I'm just writing, suppose here instead of this it was written 1,20,000 rupees. So what does this mean? That in order to earn 40,000 every year at the rate of 10%, you should invest 1,20,000. But since I'm asked only to invest 1 lakh, that means I am very happy. I have to invest less and still I will get this return. That means on my money, I am getting more than 10%, because 10% return, we need to invest this much and I am asked only to invest 1 lakh only. So hence I am getting more than 10% return. So when NPV is positive, it means you are getting more than the rate of interest. If NPV is negative, it means you are getting less than rate of interest. And if NPV is 0, this means that you are getting exactly the rate of interest on your own money. Now, whenever you write here present value of cash inflow, you should always think that this represents how much you should invest. How much? It is not visible. Just a second. Yes. How much you should invest to earn 10% return. And what does this line means? what actually you are investing. So this is NPV because basically you are subtracting present value of cash outflow from present value of cash inflow. So this is the net present value, but you should understand what NPV implies. Now this question can be made a big, huge, complex question. How? This is simplest version of the question. These are inflows. Now inflows, I have clearly mentioned to you 40,000 every year, 40,000 every year, 40,000 every year. But this figure can be written in a paragraph form, that there is a company, there is a project, then that project there is a maintenance cost, tax will come into picture. Basically this figures will not be given to you directly. You have to compute the cash inflows. But ultimately this type of calculation is to be done. Then in this question, it was given how much is the outflow. So I was just doing the project evaluation. Now while doing project evaluation, we have used which factor? We were given the future cash inflows and we had to compute the present value of those. When we computed present value, we checked that okay, this much amount should have been invested and we are investing 1 lakh. So hence we are not getting 10% on our amount. So basically you are using present value factor. Maximum times we use present value factor. We bring all the cash inflows to present value. Why? I have just told you. Now, can this calculation be shortened? Can this calculation, instead of doing such a big calculation, can this calculation be shortened? Answer is yes. Please observe this. You have multiplied 40,000. I need your complete attention because I am going to tell you present value annuity factor. This is just present value factor. So please focus your all attention on me. 40,000 is multiplied with 0.909. So you get this figure. Plus, then you add this figure to this figure. How this figure is derived? 40,000 into 0.826. Then 40,000 into 0.751 and then you get this figure. So I want to write this again on a piece of paper. See, 40,000 into 0.909. This was coming out to be 36360. Then 40,000 into 0.826. This was coming out to be 33,040. Then 40,000 into 0.751, this is coming out to be 30040. So total was coming 440 and this was present value of cash inflows. Now basically you have added these figures. Now can I write like this? 40,000, same thing I am writing again, 0.909 plus this figure as we have written, plus 40,000 into 0.826 plus 40,000 into 0.751. Now can I take 40,000 common? What is left? 0.909 from this bracket, plus sign 0.826 from this bracket, plus 0.751. What are we trying to compute? Present value of cash inflows, right? These were future cash inflows. Then we multiplied with present value factor. We are trying to find out what? Present value of cash inflows. But in a different manner now I am trying to compute. So can I compute like this also? 40,000 into this. Now let me add these three figures, 0.909, 0.826. This was PVF for first year. This was present value factor for second year. And this was present value factor for third year, right? So basically 0.909 plus 0.826 plus 0.751. So this is coming out to be 40,000 if directly multiplied with 2.486. We could have got the same answer directly. Now what is this 2.486 means and what is its name? This is, see, now please carefully understand that instead of doing such a long calculation, if you would have multiplied only once 40,000 with 2.486, you could have got 99,440. What is this? This is future value of cash flows. And what is this? This is called present value annuity factor. Present value annuity factor. Let me explain you. And this 40,000 is your cash inflow every year. Cash inflow every year. So this is also called as future value annuity. I'll explain you. Please observe this 0.909, 0.826 and 0.751. Now 0.909 means this is the present value factor. Factor means 1 rupees. So this is the present value of 1 rupees. That means if I write like this, that if you need 1 rupee after 1 year, if you need 1 rupee, you have to invest 0.909. Now what is this? Is present value factor. Now what is 0.826 means? Present value factor 2 years. Factor means 1 rupee. So if you want 1 rupee after 2 years, this is the present value. Okay. So that means if we need after 2 years, we need 1 rupee, then we have to invest today how much? 0.826 today. This is PVF. And then the last figure is, if after 3 years you want 1 rupee, present value factor. Factor means 1 rupee. This is the present value of 1 rupee, 0.751. So if after 3 years you need 1 rupee, after 3 years, this is after 2 years and this is 1 year, then today you have to invest 0.751. So basically today if you add this up, how much total money you have to invest? If you add these 3 figures, total you have to invest 2.486. So basically 2.486 you have to invest today. This is the present value of 1 rupee. But this 1 rupee you are going to get each year. If you invest today 2.486, you will get 1111 rupees for 3 years equally. So equal amount if you receive, that is called, it's a case of annuity. So we are writing PVAF. PVAF means, basically this PVAF means for 3 years at the rate of 10%, means that if for 3 years PVAF, F means factor, factor means 1 rupee. So if you need 1 rupees, annuity means every year for 3 years, then this much you should invest today. So 2.486 you invest today, you get 1111 rupees every year. So if you want to get 1111 rupees, you invest this much today. So if you want to get 40,000 rupees every year, then how much should you invest? So basically if you want to compute, so hence now conclusion time, that 40,000 was multiplied with 2.486, then we get directly 99440. So this is called as present value annuity factor. This is the present value straight, and this is what 40,000 every year you will get. So since you are just writing it once, it is called as future value annuity. Future, whatever future cash inflows you will get every year, since you are writing it once only, so it's called annuity. Let me write the correct spelling. Annuity. So this is future value annuity. Once only you have to multiply, since you have to get 1111 rupees every year, every day, every year you should invest 2.486. So if you want to get 40,000 every year, how much should you invest? So to get 1 rupee you invest this much. So 40,000 rupees you get how much? So you have to invest, today you have to invest 99,440. You will get 40,000 every year up to 3 years. This PVAF is for 3 years at the rate of 10%. Is there any table for this? Yes, there is a table for this. I'll go to that also. But please remember this equation. While solving the question, I will not be explaining this again and again. I will assume that my dear students know this concept. That whenever there is an equal cash inflows, please understand, whenever there is an equal cash inflows, equal. If every year cash inflows are not same, I'll do the calculation like this. Like this. If every year cash inflows are different, I have to compute the present cash inflows. So how will I do? I'll multiply this with PVF. Each year I will multiply and compute. But if every year cash inflows are same, why should I multiply each year separately? I should immediately multiply 40,000 with PVAF and directly get the present value in present value. Hence, whenever cash inflows are same every year, same 40,000, 40,000, 40,000, then instead of multiplying individually 40,000 with PVF, I will multiply directly once only 40,000 with PVAF and I will get the present value of all cash inflows. Okay, so now this is the fifth conclusion. Now what is the conclusions that you have to memorize? This is the what have you understood till now? First of all, you have to understand what is PVF. PVF is 1 upon 1 plus R raised to power n. What is FVF? Future value factor. It is 1 plus R raised to power n. Now if you want to find out present value, this is to be ascertained. Present value, then future value is given to you. You have to multiply with future value factor? No, present value factor. This process is called discounting because you are computing present value. Now if you want to compute future value, this is to be ascertained. This is given. Now if this is to be ascertained, then present value will be given. Then you have to multiply whatever you have to ascertain, multiply with that factor only, and you are computing future value. Future values you are computing how much future you will how much amount you will get in future. It is called compounding. So if you are going in future, it is compounding. If you are computing present value, it is called discounting. This you have to memorize. Then what new thing you have learned? That what is NPV? NPV is what? Present value of all the cash inflows that you will get in the future minus present value of cash outflow. This is called NPV. But my students should not learn NPV like this. You should say how much should have been invested and how much we are actually investing. Are we investing less or more? Answer can be plus, answer can be negative, or answer can be 0. Okay, so basically this represents how much should we invest if we want to earn cost of capital and how much actually we are investing. Okay, then new thing now we have learned is that if we want to compute the present value and future values of cash inflows are equal, so we can directly take future value annuity into multiply with present value annuity factors. This is to be ascertained. Since every year cash inflows are same, so instead of taking individually, you directly multiply one cash inflow with the PVAF. What is PVAF? Present value annuity factor. This we have a table for this also. So this can be computed with table, or can we do this calculation on calculator also? Yes, we can do the calculation on calculator. How? Basically PVAF in our example for 10% for 3 years was how much? We added 0.909 plus we added 0.826 and then we added 0.751, which came out to be 2.486. Now can we do this calculation on the calculator also? Yes, we can do the calculation. What you have to do is you have to calculate this. Then this is basically what? PVF for first year. This is PVF for second year, and this is PVF for third year. So you have to compute the PVF for first year on the calculator, then memory plus, then memory plus, and then memory recall. How do you compute PVF? 1 upon 1 plus R raised to power the year. So basically, if we do calculation for this 1 upon 1 plus, why am I focusing so much on calculation part? Because normally student do question correctly, but the computation part they do wrong. 1 plus 1.10 raised to power 1. This is your 0.909 plus 1 plus 1 2. This was your 0.826 coming, and plus 1 plus 1 plus 0.10 cube. This is 0.751. This should come out to be 2. How much? 486, right? So same thing I'll do on the calculator. There should be no memory sign above. Your calculator should not have any memory. It should be clear. Now 1 divided by 1.10 equal to 0.909 is coming. Then I'm going to press memory plus. Can you see memory plus? I'll add memory plus. Then I will do next calculation, this calculation. How will I do? 1 divide by 1.10, then equal to, again equal to, because second year, this is 0.826. Now I'll add this figure into memory plus, second year figure. Then again I will do the third year figure. How will I do? 1 divide by 1.10 equal to 3 times, because cube root. Then I will add memory plus, and then since all the 3 figures have been added in the memory, I will do memory recall. This is coming out to be 2.486. Same answer. Is it clear? So this is how you are going to do if there is a case of annuity. Now we are going to learn various chapters in section A. In those sections, basically, in nutshell, if I tell you, only 2 information will be given. Only 2 information. That there is a project. From that project, these are, just a second. There is going to be a project in the question, project evaluation. Now from that project, inflows will be given to you in any way, paragraph form, or some story must be created, they may create, but ultimately inflows information will be given, outflow how much is required will be given, and what is the cost of capital, that is the minimum return that you want from your money, because that is the return which you have to give to the capital providers. So this type of basic question, basic structure is this. Then lot of things new will also come up, but this is the main evaluation that you have to do in this study note, in 3 study notes. Seriously, if you believe me, only this is the calculation which is the main portion. Many new concepts will also come up, but capital budgeting, which we say, or NPV computation, is basically this computation. So if there is any, there should be no confusion regarding the why we multiply with PVF. Students should know this thing. There should be no confusion regarding why you multiply your inflows with PVF. Then this is called discounted cash inflows or present value of cash inflows. What does it mean? That this amount should be invested if you want to earn 10%. And how much you are investing? 1 lakh. What does NPV negative and positive means? Because when I will teach you IRR, there it means a lot. Positive, negative and 0. What 0 NPV means? That how much you should invest and is the equal to what you are actually going to invest. So basically you are going to get 10% of return. Okay. So this is all about your whole basic concept, and PVAF is also very important. When PVAF is to be used, when your inflows are even means same inflows every year, then you multiply future value annuity with PVAF to find out present value of all the cash inflows. So this is all about the basic concept. Now we are going to start one chapter from the section A. Thank you for this session for the basic concept. Now let us start the study note in the next lecture. Thank you.